Good evening and good morning, wherever you are. Thank you for joining, and thank you to Anindita and Sitecore User Group Bangalore for providing me this opportunity for to present on this session. Deploying Solr with Solr Operator in Azure Kubernetes. So let's get started. This is the agenda for today. I'll briefly introduce myself if you don't know me, and then we'll talk about the search options available. Although these search options can be used in other technologies as well, but I think for this session, since it is a Sitecore user group and I'm also like mostly into, oh, sorry, I'm also mostly into Sitecore development. So these search options will be in a way in the context of Sitecore, and then we'll focus our attention to Solr deployment options. Initially, we'll talk about the search options, but then we'll focus our attention to Solr and the deployment options available to us in that context. And then we'll talk about the Kubernetes and the Solr operator. I'll talk about the different terminologies that will help us understand or get us more familiar with Solr operator. Then we'll talk about the pros and cons of Solr operator. There are always two sides to the coin. Then we'll have a brief demo. The demo is actually a pre-recorded video because creating a cluster and then creating the Solr operator actually takes a lot of time. So I didn't want to waste on that one. So I just pre-recorded it. And in conjunction with the demo, I'm also going to show you the code or the PowerShell scripts, the YAMLs that I used for the deployment so that it will be easier for you to understand how I did it. And then I'll share some resources, some links, which can be, again, useful for you if you wanted to start off with Solr operator or deploying Solr in Solr operator. It will be useful for you. And towards the end, we can have the quick Q&A section. If you have any questions, just put it in the chat, and in this section, we can discuss your queries. If I'm not able to answer anything, then obviously we can take it up further later on. Yeah. So let's get started. This is about me. I'm Sumit Upadhyay. I'm working as a software engineer at iQuality. I'm based out of the Netherlands. I have more than 11 years of IT experience, and most of them into Sitecore and Sitecore development. I'm predominantly focused on Sitecore, .NET, Azure, a little bit of AWS also. And I'm certified in Sitecore 8 and 9, and more recently in Sitecore 10. And when I'm not working, I like to travel and then watch different sports. I think that goes for most of us. So let's get started. This is the search options that are available in the context of Sitecore deployment or development. When we say search options, there are actually two facets to it. The backend search, which is used by Sitecore itself, and the front-end search, which is used by the website. Over here, I'm trying to speak about the front-end website. I'm not talking about the backend Sitecore environment, because mostly for the backend Sitecore environment, we tend to use Solr by default. So these are the search options that I listed them down. There can be many more actually, but I felt these are like mostly used in the Sitecore world. Solr is the default one that we used. Azure Search or Azure Cognitive Search used to be used like for smaller websites. I'm not sure if it is relevant that much now. Coveo and then search tags, these are like kind of a little expensive or another option for search, but they are generally used for the websites. If you're having a very large website, or like there are a lot of websites that you want to manage in Sitecore, then it might be worth going for these options. Algolia is also one of the options that's available. And the last one that I listed is the Sitecore Search itself. It's the latest product from Sitecore. It's a SaaS provider. And generally, it is used in the XM Cloud or the headless one. I'm not sure if they support the XP or XM environment, but coming from Sitecore, I think it makes sense for them to support this. Yeah. So now we'll focus our attention to the deployment methodology for Solr. This is very basic or even prehistoric, I can say, actually. If you've worked on Sitecore 7 or 8, this was the de facto architecture that we used to have back in the days. It could be IaaS or PaaS. It could be like infrastructure as a service, or deployed as an app service. The Solr master slave setup is a way of distributing the index data from a single master node to one or more slave nodes. It basically splits the read and write load. So the master is more focused on the write one, whereas the slave is mostly for the read purpose. And if I if I show you, if I talk about the architecture on the right hand side, generally we'll have a CM environment which will be connected to the Solr master node. So whenever we are pushing any changes, or we are publishing any data, adding content to the CM environment, then the data gets indexed to the Sitecore master, Solr master, which is then connected to the two slaves that I have over here. So the slaves just keep on polling the master for any changes. If there's any update or a change in the master, then they get pushed to the Solr slave, which are then connected to the CDs. Now I have two slaves over here, depending on the complexity or the amount of data that you have in your website. It can be like multiple, maybe 3 or 4, or yeah, n number of Solr slaves, which can be connected to n number of CDs. And as you can see, the problem with this approach or this architecture is it's not easily scalable. It's easily configurable because it's kind of a simple architecture, and then it is a manual one. But to scale it, you need to create one more slave, and then again connect it with the Solr master. And on the architecture itself, these can be on separate VMs. So the CM can live in one virtual machine. The master can, Solr master can live in one virtual machine. The slaves can be on separate VMs also. Or we can have all of them together into one. It's obviously based on the needs and the requirements, based on the complexity or the amount of data that you have that you want to separate it out and scale it further. What we've noticed with these with this approach is generally we will have memory issues. So you set up a Solr master to have like 16 gigs of RAM, or maybe slave one to have 8 gigs, and then this one also 8 gigs. But over due course, as more and more data gets added, they tend to run out of memory. The Solr configured in itself, when we configure Solr, we allocate some memory to it. So those also needs to be scaled up. These are the issues that we noticed with this architecture, even though it's a fairly simple one. And the bigger problem with this architecture is, like I mentioned, it's kind of prehistoric. It's not widely used anymore because it's not supported with the newer versions of Solr. Yeah, so let's get to the next architecture, which is the Solr Cloud. The Solr Cloud uses Zookeeper to coordinate the cluster state and configuration. It allows for real-time search. It is highly available. The data gets split into the 3 nodes that I have over here. So it's highly available. And then if one of them dies or not working well, still we have like 2 nodes to serve the data. And if I talk about the architecture itself, now we are not connecting to, there's no like Solr master or slave. There's just one Zookeeper that is being connected to all the CM and CD instances. And then Zookeeper in turn manages these nodes, and it just keeps track of whether they are healthy or not, and whether the data gets published to each one of them so that it can be available. Again, this is also a manual setup, and it's slightly even complicated because we have to set up the Zookeeper ourselves and the Solr nodes ourselves. It's kind of manual and then complicated. But I think this one is like more widely used compared to the earlier one in current times. Yes, like I was mentioning earlier, search tags, and maybe Coveo can also be put into this one. It's a managed offering, managed Solr from search tags. There must be other providers, but I'm not aware of those. And based on the subscription or the license that you acquire or procure from search tags, you will have a Solr URL which you can use in your front-end website, and then you're basically good to go. You don't have to worry about the Solr nodes or the Solr cloud or the other settings. They basically will take care of it for you. And because they are taking care for you, taking care of it, it's kind of expensive. So for smaller websites, like 100 or 1,000 pages, it might not be the best option to go for. And then on the topic itself, Solr operator, this is used to deploy in a Kubernetes platform. So essentially, we are deploying Solr Cloud. So we get all the benefits of Solr Cloud without the downsides. So the downsides, like I mentioned earlier, which was complicated setup, manual setup. So we are kind of automating it with the Kubernetes. And yeah, Solr operator is actually the official way of managing Apache Solr ecosystem within the Kubernetes cluster. It's kind of a smart helper that makes it easier for us to manage and run Solr within the Kubernetes cluster. So suppose you just want to stand up a Solr cloud instance, you just tell it like, I need this version of Solr, I need these many replicas, and it will do it for you. We'll discuss more, obviously, in the later slides. Now a little bit of Kubernetes, because we are deploying the Solr cloud or the Solr operator in the Kubernetes platform. It makes sense to have a brief discussion about the Kubernetes platform also. It is an orchestration platform for the containers. It is open source, and it is used for automating the deployment. And it takes care of the scaling and then the applications themselves. The next point, one of the advantages of Kubernetes is like all the applications which are known as services in the Kubernetes platform. They can communicate and discover themselves seamlessly within the cluster. We have automated rollbacks or rollouts without zero downtime. So we will have like different replicas available for the application or the service, and then like if one of them is not working, the other can take place, and it will be up in no time. Yeah, it is also healing, like I mentioned. There can be like 5 replicas of the service, and then if one of them goes down, the other one can serve for the time being, and then while the dead one is like is being spawned. Yeah. Some of the terminologies that will be useful to understand the Solr operator and deploying Solr operator. CRDs, custom resource definitions, Helm and Helm charts. I can speak about them like together. Like when we are deploying or developing a .NET application, for example, we use NuGet package manager. Helm is kind of similar. It's not the same, but it's kind of similar. So suppose we are deploying or developing a .NET application, and we need, say, newtons of JSON package or a DLL. We don't download the DLL and then refer it into a project, right? We just use the NuGet package manager, and in the Visual Studio itself, we just search for the newtons of JSON package. And once we have it, we can just use it in our repository, and we are kind of good to go. It is kind of the similar case with Helm. Helm is like the package manager for Kubernetes. So inside Kubernetes, we have, it's kind of open platform. We don't have anything else in there. There are like different packages that are being developed and made available, and then we can use those packages inside the Kubernetes, and Helm helps in that purpose. So it is kind of the package manager, and then the packages themselves that Helm is managing, they are called as Helm charts. And these charts, they will have some settings, some definitions, which will be used by the Kubernetes, and these are called as custom resource definitions. So these are the Helm and Helm and charts and custom resource definitions. Now, these services inside the cluster, the Kubernetes cluster, are actually they do not have access to internet or the outside world. To make the access available, we need to use the ingress controller. So ingress controller is kind of the application gateway, which will be used for communicating with the outside world. And the next one is the kubectl. Kubectl is the command that we will use to run. It's a CLI to run the commands against our clusters. Now, what are the advantages of Solr operator? Since it is in Kubernetes and it is in a declarative kind of a deployment, so it's easy to manage and repeatable. It's infrastructure as code. So suppose I have a Solr cloud already available and I just need one more instance of it, I can create like one more replica. And once I do it for one instance, it's easy for me to create it for another environment or another instance. This, yeah, it's inside the Kubernetes, and because of the replicas, multiple replicas that we have, it is easily scalable and it's highly available. When upgrading Solr Cloud is fairly easy. We will see that we will have a YAML which we will use to create our Solr Cloud. Now, if we wanted to upgrade, we'll just issue one command. With one command, we'll be able to update the Solr Cloud. Now, what are the challenges? The challenges are actually fairly related with Kubernetes. The learning curve and the complexity is quite steep. It's like you will learn about Kubernetes, but then when you're developing it or creating a cluster, you will get stuck. It's harder to learn, but yeah, the more and more you practice, it's easier then. But initial, like you need more investment of time to learn, and then yeah, there are high chances you'll get stuck also. There are alternatives available, like the Solr Cloud, if you wanted as a standalone, like we had earlier. Those are one of the alternatives, and the other one is obviously the managed cloud, like search stacks, for example. If you have like a very big website, or if you can bear that cost, then search stacks might be the better option. Then you don't have to worry about Solr operator or Solr Cloud or anything. It's just like they are taking care of it for you. And also, one of the challenges of Solr operator is if you do not have your Sitecore environment in the Kubernetes cluster, then it might not make sense to go with this option. So if you have your Sitecore in Kubernetes, then obviously it makes sense because you already have the cluster and the environment. Then on top of it, you can just have your Solr Cloud as a separate namespace in the same cluster. Then it's easier. But if you have a PaaS or an IaaS architecture for the Sitecore, then having just Solr operator for the search, it might not make sense. Yep. And these are the changes. Then we shift to the demo. Before shifting to the demo itself, I wanted to show you the content, show you how I actually deployed. These are the prerequisites. I just created this one. I'm going to publish it in the GitHub. Then it will be available for everyone. But these are the scripts that I used. The first script I used was the login. This one to log into the Azure portal itself from the CLI, and then I used this script for deploying the registry. For this scenario, actually, deploying the registry is not that vital or not that important because we are not dealing with containers over here. This might be more useful in the Sitecore context when we are deploying the Sitecore containers in our Azure Container Registry. But I just have to briefly talk about it. This is the PowerShell script for it. I'm just using these parameters, the ACR name that you want. These are the default values that are provided. At runtime, you can obviously change it. And these are the write host commands or the console write line commands in a way that I'm writing, so that once you issue the the deploy registry command, then the user can know exactly what parameters or the variables values will be used for the deployment of the registry. Yeah, and then the registry will get created. Yeah, and the next thing will be obviously to deploy the cluster itself. So since the Solr operator will reside inside the Kubernetes cluster, so the next step will be to create the cluster. And this is the command that I will use or I have used in the recorded video. I'll use this PowerShell script, and then in the environment, uh, I have two values. So if I go to the cluster PowerShell script itself, I have this non-PRD and PRD. These are the valid values for the environment. It can be these are actually used over here. These are the ARM templates, PRD JSON and the non-PRD JSONs. These are actually fairly straightforward. Over here for PRD, I'm actually using more resources, and for non-PRD, I'm using less resources. So that's why it makes more sense to have like a bigger VMs for the production environment rather than the non-PRD ones. Yep. Sorry. And yes, we can provide the prefix. Over here, I'm providing Sitecore, but obviously you can change it to what you want. And then as part of this script itself, I'll show you, I'm actually attaching the cluster, the Azure Container Registry to my cluster, so that if I am deploying any containers to the Azure Container Registry, then it can be connected with the Kubernetes cluster. Yeah, and just a brief overview of the PowerShell script itself. Again, over here, I'm just showing the values that will be used for the deployment, the prefix, and then I'm not taking like this is over here. I haven't specified the resource group name or the location and the yeah, this one I am using, but the location and resource group name I'm not providing. But these are like valid parameters that can be provided when running the script. Yes, this is the command to create the resource group itself, and then this is the command for actually deploying the Azure Kubernetes cluster, and it will use the deploy JSON in conjunction with the parameters based on the environment value. So if the environment value is non-PRD, then it will take this one. If it is PRD, then obviously it will take this one. And in the Azure deploy JSON, we have the variables, we have the values that will be used as default for deploying the cluster. So the prefix, the location, AKS name. I think these are all the parameters in this item. And then these are the resources that will get deployed. I'm specifying the subnet for the deployment, and then I think this one is the more interesting section where I'm specifying the VM, virtual machine scale sets for deployment. The Kubernetes is always deployed on the Linux VM. So this entire section is for the system node itself. It's for the Kubernetes, not for our Solr operator. But this one is. So I think I missed out on specifying one point. The Solr operator is always deployed on the Linux OS machine, not on the Windows. So that's why this section is for is where the Solr operator or Solr cloud will reside. And the other one, this one, I am actually using for populating the indexes. This might not be used by you, but for my purpose, I actually wanted to use the code image that is used to populate the indexes. So that's why I created this one, but this can be redundant for you. Yeah. So once we have the cluster, yeah, these two commands are actually used so that I can have it inside the Visual Studio Code extension. And then we come to the actual command that will be used for the Solr operator for configuring or for creating the Solr operator. And It's actually very simple. We just need to add the repository, Helm repo add Apache Solr, and then we have to update it. So if I go to this website, actually, we will, yeah, we will see all the uh, operator versions that are, this is similar to Apache Solr, like we have 811 or 882. It's similar to all the versions that is available, but here we can see all the list of Solr as well as the Solr operator. And we also need to update it. And then uh, once we've added the Solr operator repository, we can install it using this command, the kubectl create command. And then we need to just get all the custom resource definitions in our repository. After this, I'm actually creating a namespace because I want to logically separate. So I want the Solr operator to reside in one namespace and the Solr itself, the Solr cloud itself in one namespace. So that's why I'm creating this namespace. And then I'm issuing this install command to finally install the Solr operator in my Azure cluster, Kubernetes cluster. And I'm also using these values. So I'm providing this -f statement along with the Solr operator values, which is actually over here. I'm just specifying that the node selector should be Linux, and then the Zookeeper, which is actually getting installed or configured by itself by default, also specifying that it should use the Linux OS. Yeah, once this one is created, then I am actually installing the Solr Cloud. So once we have the Solr operator, which is the orchestrator for Solr Cloud, once that is configured, installed, and on top of it, we can install the Solr Cloud. Like I mentioned, this namespace is used for the Solr Cloud, and then this command, the Apache Solr/Solr. Over here, we have the Apache Solr operator, and then these are the versions that I'm using, and the namespace, like I mentioned. And yeah, I'm using the Solr Cloud values, which is actually over here, the YAML, where I'm specifying the values. So I want the Solr repository to be Solr, and then this is the Solr version that I'm installing. If you wanted a different version, say 811, for example, then you can just specify the value over here. And the replicas I've stated as 3. Yes, depending on your need, it can be 3 or 5 or X. These are the addressabilities. I'm trying to configure ingress controller over here, but I didn't use it myself that much. And the pods options. So again, I'm specifying, like, since I have 3 nodes, one the system node, the other the Linux node, and then the other one is the Windows node. Over here, I'm trying to specify where do you want to install the Solr. So over here, I'm just specifying that you install it on the Linux one. And also, since we have like 2 Linux nodes, like 2 OS with Linux operating system, I'm specifying that you use the user mode and not the system mode to install the Solr. So this will be installed in the second Linux node, which is the user one and not the system one. And similarly for Zookeeper, I'm specifying the same values. Yeah. And finally, once all these things are done, I'm actually populating the cores from the Sitecore one. So this is the Solr init YAML. And over here, I'm just taking this Sitecore image and providing this connection string. I have used this value. So my indexes will be like Sumit underscore web index, Sumit underscore core index, Sumit underscore master index, like that. And I can show you the cluster itself from this one. Yeah, these are the default namespaces that are available, and these are the two namespaces that I configured. One is for the Solr operator, and the other one is for the Solr cloud, where the Solr cloud will be installed, configured. And like I mentioned, there are actually there are 4 nodes, but these are like the 2 replicas. So since we will have 3 Zookeeper and 3 Solr nodes, it wasn't sufficient to install it in one. So that's why it actually created 2. So we have 000 and 001. But when I initiated the command, there was only 1. And you should see a job over here, Solr init. Yeah, this job was actually used by this YAML to actually create or populate the Solr indexes in my Solr. And in the network, this is an interesting one. In the services, we will have these. The Solr Cloud common is the one that we'll use to port forward. Port forward is a way, like I mentioned, the cluster inside cannot talk to the outside world. But through this extension, we can actually map it in our local, and then we can use it. So if we use this one, then we'll be able to any of the Solr clouds. But if we use this one, for example, then we are specifying like I want to use just the 01 and not the other 2. But I think it's a good idea to use this one because it's a cloud and we don't want to be specific on one. Yep. And these are the custom resources that gets configured or added. Yeah, these are some of the values, Solr backups. And quickly, I can show you the cluster itself before I open the video. Yes, go back to the README. I used the Sitecore infra. So I actually had SUG infra also, but that didn't work out properly. So this is the one, and this is my Azure Kubernetes cluster. And yeah, over here also, basically you can see the same values that you were seeing in the Visual Studio Code. So we'll have these two, Solr operator and Solr namespace. And then in the workloads, if I filter it by the namespace, there should be 3. This is the job that got completed for populating the indexes, but Solr Cloud 1, Solr Cloud 0, and Solr Cloud 2. And then these are the 3 Zookeepers. So you can see that I actually use just a handful of commands, like these 2, and then the earlier commands were used to configure the cluster itself and then the registry. But actually, I'm using just these commands, like 2 over here, and then maybe few more, and that's it. We are done, and we get our Solr Cloud up and running. And yes, the node pools, like I mentioned, there are 3 node pools. One is the Windows one. It's showing fail. I'm not sure why it was running. Maybe it's not used anymore. That's why. And Linux, there are 2 nodes inside this one because one was actually not sufficient to host all the Solr Cloud and Zookeeper. And then the other one is the system node itself, which the Kubernetes will use itself for the orchestration. Yep. I can quickly start the video. I try to trim it down as much as I can. So now I'm trying to deploy the registry. And if you see, I will stop in between. So even though I have like trimmed it down further, it's still 17 minutes. So now I'm trying to issue the command for deploying the registry. And the next one will be, I'm just trying to view the values. And this SUG ACR got created, and then the SUG ACR containing registry got created. Now I'll try to issue the command to deploy the cluster. I'm providing the environment as PRD and then the prefix as Sitecore. Yeah. Now I see that these values will be used for the cluster. And now starting the deployment. I think I will have stopped the video again. Yep. So the cluster got created, and now it is trying to attach the Azure Container Registry to the cluster. And after that, the Sitecore infra got created, and then the Sitecore AKS. Yeah, the node pools were taking a lot of time to create. So I think I would have stopped the video once more so that this process can take place. Maybe I can go a little forward. Yeah. Finally, these three got created. Yeah, initially when the cluster got created, the Windows one was having 2 instances or 2 nodes, but then it automatically scaled down. And initially, like you can see over here, you can pause the video, the Linux one had just 1 target node, whereas the Windows one has 2. It was the initial deployment, but when I issued the command to configure Solr Cloud or Solr Operator, then this one got scaled up by itself, and this one got scaled down again by itself. So that's good to know. Now, once these are created, I can go forward and issue the helm command. So I'm trying to add the repo, but I had already done it previously, so that's why it's telling me that it already exists. But if you're doing for the first time, then you will not see this message. And these are the stuff available, so we need to issue this one so that we are on the latest. And now I'm trying to use this command so that I can have the access inside the Kubernetes extension inside Visual Studio Code. So now it is merged to my kubeconfig file. Now I will have access to the Kubernetes extension inside of Visual Studio Code. Yeah. So after that, after adding the repository, we try to add So over here, I'm trying to use all with dependencies. There are other options available for this one. Like if you wanted with no dependencies, or we could choose that one also. And then I'm trying to create the Solr operator namespace, which I will use. The Solr operator itself will reside inside this namespace. because I wanted like logical separation, Solr cloud in Solr namespace and then Solr operator in Solr operator namespace. So that's why I wanted to have like separately. And then I'm finally installing the Solr operator itself. And this Helm chart is actually coming from Apache Solr. So Apache Solr dash slash Solr operator. And then this is the version. Actually, the latest version is 0.8.0, but I used 0.71. If you wanted to use any other one, that's also possible. There's also a version matrix for this one. So you need to ensure that if you're using 0.71, then you need to use a certain version of Solr. It's kind of similar to what we do with Sitecore, like Sitecore 9 with a certain Solr version. Similarly, Solr operator also is tied up with the Solr cloud version or Solr version. So you need to ensure, maybe I can show it quickly after this. Yeah, when we are on the resources, when we're discussing the resources, then maybe I can show that one. So now the Solr operator and Solr operator zookeeper operator is being created after issuing this command. And now finally, I'm creating the namespace where the Solr cloud itself will get configured or added. Yep, I'm basically copy pasting the command and then changing the namespace. And then I'm using the file over here, Solr cloud values, to provide the custom values that I want. So it's getting installed. And normally, like you'll be able to see soon that it takes time to create, like even though it shows that it is like the Solr namespace itself is actually not available. But if I go to all namespaces, you'll be able to see. Now, if I go to namespaces once more and then the pods, we'll see that it's the namespace itself is actually not available. But if I go to all namespaces, it's actually creating. So the namespace was actually not listed over there, but it was creating. Maybe there wasn't any resources at the time, so that's why the namespace didn't get listed, but it was actually creating. And again, the creation is actually not done for anyone. Like there are 3 Solr Cloud and 3 Zookeeper, but since none of them got created, so maybe that's why the option was not available then. Yeah. So now finally, one of the Zookeeper got created. And then also after this, you might see an error, which was slightly confusing for me. I was thinking that something was going wrong, but actually it wasn't. It's just that the node pool, like I mentioned, it was adjusting the values. So it was scaling down the VM Windows node and scaling up the other one. So now the Zookeeper is in pending state, and we might see an error, but it's actually just adjusting the node pools while this one is in the pending state. So that's also good to know. Like I was kind of worried that it's going bad or it's not going good, but it was actually just pending and it was waiting for the node pools to adjust and scale up so that the other Zookeepers could be deployed. Now you see the scaling down message over here. And then this one is still in pending state because the Windows node needs to scale down and then the Linux one needs to scale up. So once we have both of them, then it will be able to configure the Zookeeper. Maybe I should move forward. So now you see that it's succeeded. And then finally we reach the container creating status for Zookeeper. All this while this one was in pending state, but after the node pools got scaled up and down, the Linux one was scaling up, Windows one was scaling down, then this one it was able to create. And after that, we finally have all the Zookeeper and Solr Cloud available. And these are the vitals for the Linux nodes. And now I can change the namespace. I can use the Solr namespace, and then yes, in the services, I can just port forward the common one. I'm just verifying the nodes over here as well. And these are the pods that got created. Again, 3 for Solr Cloud, 3 for Zookeeper. Yeah, with this option, like I mentioned, the services are actually not available by default. It's using this Solr port forward option that we can access it from the local machine. So now I can just go to localhost 88. 88 is the port that I specified over there. And now you can see that there are actually no cores or no collections available. So there are actually other ways of creating collection, but I use the Sitecore one, the Sitecore YAML. So I'll again issue this command, kubectl apply -f, and then I will provide the Solr init YAML. Now the job is kind of created, and then it will be in running state. Once it's completed, then we should be able to see about the YAML itself. I'm just trying to specify over here. Now it's still creating. It also takes like a minute or two to create. Now I'm checking the job, checking the logs for the Solr init job. Yep, so everything went right over here. And we should be able to see. Yeah, so one of the cores is available, and then the others should also come in. It's just like takes a little time to come. It's still in running, so it's still working. When it's complete, and then we should see the 3 ones. There was actually one thing that went wrong in this video. Like you could see Sitecore master index, web index, but there are actually no cores attached to it. So there are 3 Sitecore ones, but then there are no cores. So to fix it, actually this morning itself, I changed it to my name, like Sumit, and then we have the 3 collections. Yeah, maybe I can just skip forward. Yeah, that was pretty much it from the video. Can just stop it. And now I can just port forward once more to the existing one. So I can port forward like the same way. Again, I can use any port number. Actually, it's just sorry. Yeah, I can quickly go to localhost 88, and this is the Solr instance that I have, and I have it as Sumit Web Index Master and Core. And for the 3 months, I have like 3 cores available. Yeah. Going back to the slides, these are the resources. I did mention about the version matrix. So if I open this one, they do talk about version compatibility and upgrade options. Version compatibility matrix. So the Solr operator version is like, if we are using 0.7x, then this needs to be the Kubernetes version. So I used 1.25.6, but so it needs to be higher than 1.21. It cannot be below that. And the Solr version, 4.7x, it needs to be more than 7.7. But if you're using the 0.81, we cannot go with the Solr 7.7 version. It needs to be higher than 811. Yeah, and maybe I can open these links. This is the Kubernetes Solr Cloud website itself, and this is the tutorial section, or resources section of it. These are some of the tutorials that are available and quick and handy to get started with it. Some of the documentations, some of the YouTube videos that will help you understand and get to know a little more. And this is the documentation website. Essentially, I use these commands, but this, I think they are using to run it in the local one, but or maybe not. Yeah, these are the documentations. And there's also a nice blog from Jeremy Davis from Sitecore community itself, where he also tried to install the Solr operator in his local machine. He had the Docker desktop running. We usually will have the Windows version, Windows containers running. So we need to switch back to the Linux one and then enable Kubernetes, and then we can again issue those commands once more, and then we can be set up. Yeah, I guess that's it for me. Are there any questions?